Good morning friends. I am Dr. Atiqur Rahman. I am a faculty at the Department of Geography, Jamia Millia Islamia. Today we are going to learn a module and the title of module is GIS Data Structure, Vector versus Raster. In this module the learning objectives are what are the different GIS databases, what are the sources of different GIS databases, what are different types of GIS database, and in the next part we will be specially talking about the vector data models and raster data models, and there are different types of raster data models and there are different types of vector data models. So, we will try to understand what are these data models, what are the structure of these data models, what are different characteristics of these data models, what are the different properties of these data models, and also what are the advantages, what are disadvantages of these data model. Because in today's world when we are talking about a GIS and remote sensing, everybody is using the satellite data, everybody is using in GIS software to assess, understand the spatial problems, whether physical or natural, whether human or man-made or natural. So, all these problems is to be solved by using different data sets, and that is the data set that is coming from different sources, and these data sources, whether satellite data or any other data in the form of map or in any other format. So, what we have, we try to understand what are these different data, what are different types of data, say for example, spatial data in broad categories and non-spatial data. So, we will try to see what are these spatial data and what are these non-spatial data, and how we can create a GIS database and how we can use these databases for different problems. So, by and large in this module we will try to understand these concepts and these data types and these formats and how we can use these data for different problems. So, before going to GIS data structure, we should understand what is a data and what is GIS. You must have studied GIS in the GIS module, is art and science of acquiring information, storing, manipulating, assessing, analyzing and retrieving at the will and manipulation of the data. So, it is a computer based software technology wherein we use different data. So, one need to understand what are different data structure that a GIS software can support. In that process we are trying to understand raster and vector. So, before going to raster and vector, let us understand what is a data. You all know what is a data. If I ask you what is a data, you will be in a position to answer what is data. Let me tell you something more about the GIS, about a data. Data is nothing but is numerical values which are there for representing any particular phenomena. If I say population distribution, if I say population density, if I say number of trees in a particular area. So, once I say 1000 population, 1 lakh population, 10 lakhs population, or if I say population density maybe 150 persons per square kilometer, all these are the data. So, data could be in the three form. One could be in the form of number, which I was telling you. Data could also be in the form of, say for example, text. Say for example, if I say black soil, if I write black soil in text, so that is a data which separates black soil with the alluvial soil, which separates black soil with the red soil, which separates red soil with the laterite soil. So, if you write something, if I write 1 million population in a text, that is a data. Now, third form of data, data could be in a form of symbol. If I draw any symbol, that could be a data. Say for example, for electric pole we have a symbol, for trees we have a symbol, for the grasses we have a symbol, for a temple we have a symbol. So, if we draw any symbol on a piece of paper, on a map or a topo sheet, what we have, we can count it and we can see these are the features, phenomena which are there on any particular part of surface of the earth. So, broadly speaking, data are in three form: number, text or symbol. Now, let us understand the information. Information is little different from the data. Information is nothing but any degree of sensitivity that we extract from the data, that is information. If I say you are a class of say 50 or 100 students, if I say ki out of 100, 80 students are having marks more than 60%. So therefore, what is that? I can say information, I can extract the information based on the data that 60% students are having marks maybe 80%. So I can say this class is very good, or this class where the percentage of marks is very good, that means the students, the quality of students are very good. So that is information. So geographic information, we can say now geographic is nothing but is any surface feature which are there any particular part of surface of the earth is a geographic data, and from that data if we draw any information, that becomes a geographic information. And when we say system, when we put all these data, geographic data in a GIS environment, and if we try to analyze, if we try to extract something, so that for that we use a particular system, we apply a particular model or any logic or method and methodology. So now let us see what are different types of data, geographic data. So data can be classified broadly into two classes. One class is called spatial data and second is called non-spatial data. The moment I say spatial data are nothing but a data which is in the form of maps, which is on a piece of paper. So I can say that spatial data, say for example topo sheet, a cadastral map, or any data in a form of say aerial photograph. You must have learned photogrammetry in the earlier modules and other modules. The most recent important one is the data in the form of satellite pictures. So satellite data, topo sheet, cadastral map, or any data which is there on a piece of paper that has been surveyed, that has been plotted, that becomes a spatial data. So spatial data is of immense use, and that is being used in GIS software, in GIS environment to solve, to assess, to analyze any problem or to give a solution to any problem on any part of surface of the earth. These problems could be social, economic, human or natural. So I will talk about this spatial data little later in detail. Now second is the non-spatial data. Non-spatial data is also called as attribute data, which is in the form of tables. Say for example, and the best example of the non-spatial data is the census data. Census data which is in the form of tables, which are arranged in two-dimensional table in X and Y, X rows and Y column. So these are the non-spatial data. Now in GIS domain, what we do is we integrate the spatial data with the non-spatial data, or we can say non-spatial data with the spatial data in order to draw meaningful representation of any particular part of surface of the earth. Say for example, if I take a spatial data, say district wise map of a state, Uttar Pradesh, Bihar, or you talk about Kerala, Assam, that is the spatial data. In spatial data we have the census data, wherein we have the data on population, total population, male population, female population, literacy, child labor, working population, agricultural labor, landless labor, and so and so. So all these data can be linked with the spatial data, and we can draw or plot or represent meaningful thematic information of any particular state. So let us talk about something more on the data. So if we talk about any data which geographic data which gives you a specific location in terms of X and Y and Z also, basically X and Y. The moment I say geographic location of any particular feature or phenomena in the form of X and Y, that is a latitude and longitude. We all know what is a latitude and longitude. Suppose if I am standing in Delhi, so Delhi's latitude longitude is somewhat 28 degree latitude some minute and 78 degree longitude and some minute and some second. So, if you draw a line of latitude and longitude in a form of cross, this particular pinpointed location is the the information or the location of any particular phenomena or the which are natural or the man made. So, that is the geography. And the third dimension, if I add Z, that means the elevation. If I talk about, I was giving example of Delhi. So, Delhi is located is situated at a height of about 230 meter above mean sea level, something like that. So, that is the Z data. So, if I move from this place to another place, from another place to another place, since the topography is varying, it is not flat. So, Z value changes. If I move right and if I move front, so what we have, X and Y values also get changed. Therefore, the location gets changed. When the location gets changed, the feature which are there is varying. At one location we have another feature, at another location we have another feature. So, therefore, what we can say that data is recorded or is there in terms of extent, spatial extent, that we can locate in a form of X, Y and Z also. Now, all these information X and Y, Z, we can get it from the topo sheet, we can get it by using GPS, we can get it from any other map which is surveyed maybe 10 years, 15 years, 20 years before. So, all these data can be accessed, can be acquired, and that can be present in spatial form. The non-spatial data which are there, that cannot be linked and can be presented in spatial form. So, now let us understand what are different data models. So, broadly speaking, as I said in the introduction, that there are two broad data models. One is called raster data and second is called vector data. Now, let us understand first what is raster data and what are different types of raster data. So, raster data is nothing but is a data which is a spatial data. Now, first understand raster data is a spatial data, is not non-spatial data, which could be in a form of topo sheet, which could be in a form of scanned topo sheet, which can be in form of a map, a scanned map, which can be in a form of aerial photograph, digital aerial photograph or analog aerial photograph. It could be in a form of satellite data, which could be in a form of analog data or digital data. Since today is the age of digital India or digital drive whole of the world. So, we have the satellite data which is in digital form. So, what do we have? We have a satellite data which is in digital form. So, that is all these data what I have named is a raster data. Now, what are the qualities, what are the characteristics of raster data? Raster data are arranged in column and row in a form of cell. Each cell, these cells are square in shape. Each cell has its unique value, that we call is a pixel values or picture number or DN values, or we call is a digital number. So, each cell has a unique number. Adjacent to that cell, there could be another cell. I will show you in the diagram figure 1 and figure 2 and figure 3, that will gives you a very clear understanding of what is a raster data. So, raster data is a continuous data which are arranged in a column and row I and J, column I and row J. So, these are arranged systematically. So, raster data are of two types. One is called discrete data and second is called continuous data. As I was giving an example that raster data, there is discrete data, that is the data which is in the form of pixels, square in shape. So, each pixel has a unique value, each pixel has its unique value. So, what do we have? This data is a discrete in that form. As I said that one pixel may be having a value of 120, another next pixel adjacent to it on the right side may be having 130, on the left side of it, it may be having 110. So, what do we have? That this way is a discrete data. It's a discrete data. It's arranged in a series of rows and columns. So, this is a discrete data. One could be a very fine example of discrete data is, say for example, road. it could be polygon, it could be a point. Okay. Now, once I say that continuous data, second type of raster data is a continuous data. Continuous data, if I give an example of continuous raster data, say for example this is a hilly slope. So, it is continuously, the height of this mountain terrain is continuously increasing, slowly increasing or slowly decreasing. So, therefore, in that way what we can say is a continuous data, where the values is changing, values is increasing or decreasing. In values I mean the height information, the slope information. Slope could be in a degree, slope could be in a percentage. So, these are the two basic classes of raster data, continuous data and raster data. Now, let us understand what are the advantages of raster data and what are the disadvantages of raster data before going to vector data. Raster data, as I said, is a continuous data. It is in the form of cell, the pixel values, brightness value. You must have learned what is the pixel value or what is the DN value. Let me tell you a little bit here that the sun's energy which is coming on the surface of the earth, and that sun's energy is being reflected back to the atmosphere and then back to the sensor which are there in a satellite. So, from one cell, if you have one cell of say for example 15 meter or 5.8 meter Indian satellite data, P6 data, 5.8 meter spatial resolution, from that grid 5.8 by 5.8 meter or 15 meter by 15 meter or Raster data of 28.5 meter by 28.5 meter, from that grid what the energy is going back and that is being recorded at the sensor, that is a digital number. So, another advantages of raster data is that if you want to do any analysis, a spatial analysis, overlay analysis or any analysis by using GIS software, for that you need to have data in a raster format. If the data is in a vector format, that can also be used, but the raster format data is good for overlaying, buffering, proximity analysis and so and so. So, what we have, if you take any raster data which is at a scale of 1:50,000, which has say for example, if we take a grid of 3 millimeter by 3 millimeter, that covers an area of about 2.5 hectare. So, what we have, this is another beauty of the raster data. Raster data, once you keep on breaking or if the grid size becoming small, that means if the spatial resolution keep on increasing means if the 5 meter data is there, so size is small, resolution is better, clarity of the surface feature will be better, but the area coverage will be small. If you have a data of say 30 meter or 36 meter, area coverage will be large, but the details will be less. So, what we have, if you have a better resolution data 5 meter or 4 meter or 1 meter, the size of the data becomes more. So, the disadvantage is that it needs large storage space, the raster data. Keep on going the better resolution, the size of the storage or the size of the pixel values increases. Say for example, if I take 23.5 meter data, IRS data, so if you break into 5.8 meter to 5.8 meter, it becomes 4 times larger storage capacity. So, storage and handling of the raster data is an issue. For that you need to have a computer which has a big storage and so and so. So, the raster data today in a GIS software, there is option that we can convert vector data into raster data and raster data into a vector data. Now, let us understand the vector data. Vector data is a discrete data, opposite of the raster data. As I said, the raster data is a continuous data, but here what we have? We have vector data is a discrete data which separate up two surface feature x and y. From x and y means if you have one land parcel, that is x land parcel that belongs to a particular person, right side of the line is a y which belongs to another person or any other land surface feature. So, vector data is in the form of represent a geographical information, geographical phenomena in a form of line point or polygon, or point, line or polygon. If we connect different points and draw those points into a circle, it becomes a polygon. So, one polygon, I said, that belongs to a particular person. One polygon, one area is belongs to a particular person, or one area is grown a particular crop, and another area next to it is grown a particular crop. So, we can separate two land surface features by using a polygon. We can also separate two land surface feature by using the line and the point. If you take a point data which represent a particular object, particular building, a building which is where we are having a particular activity, in the next building we have a particular building. Maybe if you have a point data in the form of electric pole, the next pole could be a telephone tower or something like that. So, this way vector data is a discrete data. Okay. Vector data is discrete data. If we see the different data structure of vector data, broadly speaking there are two types of vector data models. One is spaghetti model. I will be showing in the table and diagrams that will give you better understanding of spaghetti model in the figure, and the second is topological data model. Okay. So, what we have to, if we talk about the topological data model, which connects one with another, and we draw, say for example arc node. If we connect one node with another, we can get an arc. So, arc node and a polygon node. So, we will be representing, I will be showing those data models, spaghetti and topological data models through diagram that will give you better understanding. Now, what are the advantages of raster data, what are vector data, sorry, and the disadvantage of vector data? Advantage of vector data is that if you want to understand a particular area, perimeter or length or anything, for that you need to go to the vector data. We have to use the vector data model in a GIS environment. If you want to use raster data, that will not give you length, perimeter and area and so and so. So, what we have, we do vector operation from GIS, in a GIS from raster to vector in order to calculate area and all. Now, another advantage is that the vector data is easy to understand compared to the raster data, because in the raster data you have different pixel. If you take, I will show you in the diagram that one pixel is having value of 79, another is having of 80, another is having of 99. So, 99, 80, 70 represents a particular object, particular phenomenon. So, we can understand, but it is difficult to understand what feature is that. There could be a mixed feature, but in the vector data we completely separate it out. We carve out a particular feature, particular phenomena from one to another. So, therefore, it is easy to understand and is better to understand for a common person or any other person. But the disadvantage of raster data is vector data, sorry, is that in a vector data is complex in a sense that there are different boundaries, lines that are being overlaid over one another. So, if we draw a polygon over that, again there is another polygon, there is another polygon. So, there are different lines which intersect overlaid over one another. So, in that way you get confused, because on one part of surface of the earth we have particular soil, we have particular landform, we have particular slope, we have particular buildings, we have particular human phenomena, cultural phenomena. So, if you want to map all these, so of all these the boundaries get overlapped. So, in that way it is a bit complex to understand, but otherwise for area analysis, for length and all, it is easy to understand. So, these are the some of the advantages, disadvantages of vector data model. In a figure 6 or 7, I will be showing you what are the different how the raster data looks like and how the vector data looks like and how the real world looks like. So, I will show you, that will give you better understanding how we can represent the earth surface feature, real earth surface feature in the form of raster and a form of vector. Now, if you see figure 1, which clearly shows a raster data structure. wherein what you see in this diagram, that these are the grid, different grids. If you see, these grids are varying color and gray shades, and if you see on the top of it, there are different values. It may be 84, 90, 82, as I was talking before. So, all these are discrete, discrete values. These values are the numbers, digital number. Okay. So, this clearly shows that the data is in a form of grid, which is discrete, but is a continuous data, is in form of cell. Okay. So, each one cell, one set of cell is called a layer. Each cell is independent, addressed with its value, that is what I was saying, 80, 81 or 90, 120, what all. So, each cell may be having certain values adjacent to it, may be having certain other value. And I was telling you before that a minimum mapping unit at 1:50,000, which if you take one cell which is a size of 3 millimeter by 3 millimeter, that has an area of about 2.5 hectare. So, if you take couple of cells, you can get an how much area is there. So, these are the very fine example of raster data sets. Figure 2 shows vector data, wherein I have talked that vector data could be in a form of point, it could be in form of line, it could be in form of area. Now, if you see the point, one is a different point, is a dot point, it is a cross point, it is a triangle point, it could be a circular hollow point. So, all these points you can represent data in a by using any of these pictures, that is in a form of point, that is vector data. What I was telling you before is that if you see the dark point may be representing a particular feature, a hollow circle may be representing particular feature, triangle may be representing particular feature. Therefore, in this way what we can say that these are the discrete data, and which is the vector data. Now, if you see the second, there are three representation of line. One is zigzag line, second is broken line, zigzag, and the third is straight line. So, this may be a river which is moving zigzag, this could be a road broken line, this could be another road which is going straight, metal unmetal road. So, this separates one with another. Now, the third is the area. If you see this figure 2 area, there one polygon, on the second we have the one polygon, within one polygon there are two other polygons. So, that means each polygon is representing a particular phenomena or the feature, and the third is shaded polygon, this is representing another feature. So, therefore, if you see within the polygon there is something else, beyond that polygon there is something else. In that way it is a discrete data, it separates one feature with another feature. Now, if you see figure 3, as I was telling you that there are different types of vector data. One is called spaghetti data model. In a spaghetti data model, each feature, that is point, line, polygon, is presented as a string of x and y coordinate group with no inherent structure in a spaghetti data model. So, what we have, if you see the figure 3, which is spaghetti model, on x axis you see 1, 2, 3, 4, on y you see 1, 2, 3, 4. Then there are 3 polygons, one is A, B and C. Now, if you see A1, see A1, how can we identify? So, for that you have different nodes. So, say 1, 2, 3, 4, 5, then another line that is called that is the nodes 6, 7, 8, 9, 10, 11. So, by using these nodes and all, we can you can separate one with another. The polygon that lies adjacent to each other may be made up of its own strand of spaghetti. So, due to this, some redundancy within a data model is created and result efficiency is reduced. Now, the second data model that I was talking about in the vector is the topological data model. As I said that it is nothing but is characterized by inclusion of topographic information within the data set. Topography is a set of rules that model the relationship between neighboring points, line and polygon, and determines how they share the geometry. For example, figure 4 shows arc node topology. If you see this one left side, there is arc node topology. If you see here On the right side arc node list, on one column we have arc A, then from node and to node, from where to where arc extend. So, if we see A, this is A here, A extend see 16 and 17. So, what we have A extend from 16 to 17. Now, if we see similarly B, in the second column, that is node from to node 2, that is 14 to 17. So, arc B you see here vertical line, arc B extend from 14 to 17. Similarly, you can come down, say for example, arc E, E is here. So, what we have arc E, it start from 18.18 to arc node 18 or point or node same to 21. So, 18 to 21. Similarly, if you say arc H, the last arc H which start from 21 here and the bottom, and it end at 22. So, this way we can say this is a topological model. Topology is also concerned with preserving spatial properties of any particular human or natural phenomena. Another example of topology model which is under the vector data model, vector data structure, is arc polygon topology. If you see figure 5, arc polygon topology, there are two diagram, one is on left side. On the left side what we have, these are the different polygons. We have polygon say in the center D, in the top left we have this polygon B, we have on the right side northeast we have polygon C, and the bottom is F and left side is E. Now, let us understand what is arc polygon topology through this diagram. What we have, if you say B, polygon B, what are the arc units? And the arc unit is 1, 3 and 5. 1 is on top, 3 is on the right side and 5 is in the bottom. So, arc polygon which is named as a B is made from arc list of 1, 3 and 5. Similarly, if you see C arc polygon, what it comprises, it is made up of unit number, arc unit number 2 here on the top and 3 on the left side and then 4 on the right side, and then we have the 6 at the bottom. Similarly, you can have all the polygons, we can clearly understand. Let us take one last, that is D. If you see the D, it comprises of polygon D comprises of 4, 5, 7, 8 and 12, that is 4, 5, 7, 8 and 12 on the left side. So, this is how these vector data is stored in a GIS domain for any analysis. Friends, if we see this figure 7, what we have, as I explained in the beginning, that this is non-spatial data. Non-spatial data, if you see the right side is a table. What we have, as I said, that non-spatial data is arranged in 2-dimensional table in the form of column and row. So, this is a column ID, size, and then soil, then age, etc., and the right side, and the row is 1, 2, 3. It could be of any unit ID, maybe a district ID 1, district 2, these are the. If you see the left side of it, this is a map which is a form of vector data which is represented in this table. So, vector data has its attribute. Raster data which you see on the right side of it, on top of it, it has also attribute. But if you see, if you rasterize this, if you take this, convert this raster data into vector data, say for example, number 4 which is there, darker shade in the center. If you see number 4, it has size is 119, is a soil is some type of soil, age is 5, something like that. So, these are the non-spatial data which is linked with this spatial data. So, what I am trying to explain through this figure 7 is that on one side we have the raster data, on the left side we have the vector data, vectorized, and in this vector data we have the non-spatial data which is attached to it in the form of 2-dimensional table. So, friends, by now you must have understand what are the GIS data structure and what are GIS data models. wherein we have clearly spoken about raster data and vector data especially, and we have also seen what are advantages of using raster data, and we have also seen what are disadvantages of raster data, and we have also seen what are the advantages of vector data and what are the disadvantages of vector data. Before that, we have clearly got an impression and we have got an understanding of different data sets and different data bases, especially the GIS database. We have seen what are the difference between normal data and GIS database. We have seen also the spatial data, what are different sources of spatial data, right from the topo sheet to the modern age of remote sensing, and even before the remote sensing we have seen the GIS database as aerial photography or aerial photograph as a GIS database. So, I am sure that you must have got a good understanding of databases and data structure that can be used in geospatial studies and geospatial problems, for starting from social sciences to other life sciences and human studies. These data sources, we have also explained that these databases are available for whole of the world, not only for one state or for just one country, for whole of the state, especially as I said before that in remote sensing data what we are getting in the form of satellite, that is covering entire world at a repeated interval at the regular basis, sequentially and systematically. So, I do hope that you must have enjoyed today's lecture on GIS database and especially raster versus vector data structure. Thank you so much.